Unmute the speaker.
Yes. Okay. Any questions on the homework? Now, I asked this question cautiously. Now, we got like two groups of people in the class at this point. We got the people that religiously do their homework. Maybe once and twice they don't, and then the very next day they come running to me. Here's the homework. I'm sorry, I forgot to turn it in. Right? Like Brandy did. She turns in her homework, right? And when she forgets to do it, she fixes it. And then I got the other group that are like, what? We have homework in this class? Right? And it's fourth quarter.
What about the kids in the middle?
I don't really have kids in the middle.
I'm in the middle.
I have kids that either turn in homework or kids that don't turn in homework. And it's like there's really no middle. Okay, maybe one or two.
Yeah, me
Right?
neither.
But
Yeah,
not during fourth quarter.
Ooh.
I occasionally turn mine
If I
in.
counted the number of homework you turn in during quarantine, I'd need one hand.
I did all of them. 2.5 fingers. I missed.
No, it's more than two.
It was like 2 assignments. You can count.
Point being is that when I say, are there any questions on homework, I already know what. The kids that did their homework got to practice on the longest formula of the year, the quadratic formula, which is super critical important that you know what to do. The kids that didn't do their homework, we're going to get, once again, we're going to get to test day. You're going to look at a test. You're like, is this even written in English? I don't know what any of it means. Do your homework. I had two people, which I suspect I know who they are, literally turn in a piece of paper yesterday. I mean, it looked like, it was literally like that. It didn't even have a name on it. And it was in blue ink. No, I'm saying it looked like that.
Literally that.
Honestly?
It was in blue ink though. Today,
No.
all right. Hey, please put effort in your homework. And you know, as a student, as we go forward, no matter, you know, whether you stay in the school, you go to another school, whatever. In a math, listen, let me talk. When you're in a math course, do not let the professor, the instructor, the teacher get to that point where you're like, what in the world is going on? You know, it's up to you. If you're not making any effort, that's going to happen every class. But if you're making an effort and it doesn't make sense, you have a role to play. And your role is your hand goes up and you're like, Scott, what did you just do? I don't get this. There is no math teacher that will be offended by that, right? There's no math teacher like, oh, there's another stupid question I got to answer, right?
I had a
I had a fucking middle school teacher that did that.
Mr. Bates.
Mhm.
Well, this teacher will never do that. How about that? But I'm just saying that when I'm afraid that it's happening to some of you in this class, it's like you're letting the F happen to you. Like you're just saying, yeah, come on, bring the F on, right? If you don't like that position, you don't want to stay there, then you got to change. Today, I'm going to do another challenging class in the sense of it. You don't know what this is about. You've never had it before. You have no sense of where it's going or what the next question is. It means you got to stay engaged in the class. And if you do, I'm going to promise you, today is an easy class in the sense of compared to yesterday and way easier than Complete the Square. Complete the Square is the only class that I teach in Algebra-1. I'm like, yeah, most of the kids probably aren't going to get this. Half the class probably will, but the other half of the class, they're not going to get this. They're going to see this again in Algebra 2. And if they go into pre-calculus, pre-calculus. Half the class does get it. But every other class to include today that I will teach, you will get it if you make an attempt. All right, speech over. Let's get going. Yes. Let's take a look at number 10.
Anna has a question. Oh no.
I literally just gave a speech about how you're supposed to ask questions when you don't get something.
No, but that's like an oh no because Hannah knows everything.
You said number 10, Hannah?
Yeah. Because I was confused because the thing inside the
N squared.
square root equals 0.
Oh, that's perfectly fine because the square root of 0 is 0. Perfectly fine. Remember, when there's a
No,
perfect,
it was negative, and so the thing had to.
well, let's see what happens. Negative 6n minus 1 equals 0. I need everyone in the back to stop.
I know what to do.
All right.
I know what to do.
A, Hannah is,
Uh,
B is, and C is. Okay, can you do the formula off the top of your head?
N equals negative B.
Oh, yeah, I should write n, not x.
N
Negative b would give me,
6.
okay, plus or minus,
The square root of negative 6 squared.
which is,
Negative 36.
no, 36. It's negative 6 times negative 6.
That's why.
All right.
Thank you. I don't even need that.
Okay, cool.
Yep.
And I said yesterday during class, the two biggest mistakes you will make, squaring a negative and you write a negative instead of a positive, and then minus 4ac, where a lot of kids will try to do it all in their head and they'll just mess it up. Haley, you want me to finish this one? Darn it, because I already closed the book. All right. I was trying to get you to take the bait. All right, which one you want me to do? Read it.
4z squared equals 10z
So this is only ugly because it doesn't say equals 0, and we got two things we got to move over.
B.
All right, we'll stick with Z.
No, it's
All right.
like a 7.
So I just need to move both of these to that side
Why would I do that?
because that's what you got to do.
But why couldn't we move the 4?
But the formula is based upon the fact that it says ax squared plus bx plus c equals 0. If it doesn't, the formula doesn't work.
So then why don't we just rewrite the formula? Make it,
Could do that.
like, that wouldn't that be smarter than?
No. Yes.
So I moved the 4z squared.
So did I.
Well, let's see what will happen if we do it both ways. And then we'll have a complete answer. So if we move these to the other side, we get 4z squared. I'll do it real quick. Minus 10z plus 5
So that math is still
equals 0. The other way, we would get negative 4z squared plus 10z minus 5 equals 0.
I
Okay.
think we made it so we can draw ourselves.
Okay. Well, we're going to see what happens, whether it even makes a difference. Okay. So on this one right here, A, B, C. So we get z is equal to negative b, so that would be 10, plus or minus the square root of b squared. Well, that's 100. Minus, and I always write this one up, 4a. Guys, could you please stop in the back? All over 8. On this side, well, we get negative 10, plus or minus the square root of, we still got 100, minus 4 times a negative 4 times a negative 5. All over negative 8. I mean, they don't look the same. Let's see what happens. 4 times 4 is 16. Well, 4 times 5 is 20. Times 4 is 80. And a negative, we still got a negative. Right? So I get 10 plus or minus the square root of 100 minus 80. Yeah. Right? 4 times 5 is 20. All over 8. All right, let's finish this one. 10 plus or minus. That gives me the square root of 20 all over 8. Square root of 20 can be written as 4 times 5, so 2 root 5. So we get 10 plus or minus 2 root 5 over 8.
I didn't adjust it.
Notice all of these we could factor out of 2. So we can divide everything by, reduce it by a 2. So we reduced everything by a 2, we get 5 plus or minus root 5 over 4. There's 2 answers there. Yeah. Why would we multiply the? We did. We skipped a step. 2 times a was 4. 2 times 4 is 8. But you were right. On this side, we get negative 10 plus or minus 4 times 4. This is still 80, but we got 3 negatives.
It's still minus.
It's still minus 80, right? So we still get 20. And we still get negative 8. Now here comes the magic, right? This is still going to give me, it's still going to give me 2 root 5, right?
Yeah, but this is, you get the same answer if you do
Yeah,
it.
hold on, everybody, let's catch up. Plus or minus 2 root 5, we okay? All over negative 8. Now here's the magic. I'm not going to divide by 2, I'm going to divide by negative 2. And I would still get
whole answer right there?
Yeah, and this is how it's gonna be written in the book. Now remember, there's two answers here. There's 5 plus root 5 over 4 and 5 minus. The book occasionally will say, let's write it as a decimal. Occasionally will say, let's leave it as that. Neither one's fine.
What if your final answer is just a decimal?
Well, then you typed the whole thing in your calculator. That's fine.
And so you,
I don't know if the book has that. What number are we on?
16? Would you tell us what they are?
I'm going to. That's the very next thing we're gonna do. Additional written exercise is 16. It gives me both answers. What'd you get? Yeah,
And
0.7.
negative 0.7?
Positive 0.7.
That was close enough.
All right. But it also gives this answer as well too.
I like that.
It says 5 plus or minus square root of 5 over 4, and that's what we got on both of these, by the way. All right,
Oh, you did a negative 2.
here we go. I'm gonna call out well, I gave you the evens. What do you know? All right, number 2 is -1/2 and a 2. Number 4 is -1 and 4. If you don't have to write them in order, you can, but they always put the smallest one first. Number 6 is -7 and -1. Number 8, did anyone leave it as square root or did everybody change it to decimals? You did both? Okay, I'm just gonna call it the decimal. 3.3 and -0.3. Number 10, 6.2 and -0.2. Number 12, 4.5 and -0.5.
What if you rounded up, took the 6 and you made it, you have 2
It doesn't really say, does it? Right? It doesn't say round. No, it says round to the nearest 10th. It does say that. 14, 7.7 and -1.7. 16, we just said 1.8 and 0.7. And the last one, 0.9 and -1.4. I don't know why they didn't write that one for least to greatest. All the other ones they did. Yeah. So it's 3 plus or minus root 10, 10. 4 plus root 26 over 2, 12. 14 is 3 plus or minus root 22. 16 is 5, well, it's this right here. And 18 is -1 plus or minus root 21 over 4. Okay. All right, quadratic formula. Boy, are you going to use this a lot. You're going to use the quadratic formula a lot. All right, no tattoos.
Number 10 was just like,
No what?
I'm a common Jew. Like,
Were
I'm gonna
you-
get like a whole
You were
thing
here
tattooed,
yesterday,
guys,
correct?
and just pretend.
All right. Today is, I'll collect homework here in just a little bit. Today is, you don't have much. I know sometimes when you learn something like, I don't know, it's history class, we're talking about kings and queens. I know what a king is, I know what a queen is. All right, I know there's probably a war involved and there's, I don't know, somebody messes around and then they get their head chopped off. You know, if you have some idea where the story's probably going, right? In math class, most of the time when you get something new, you don't have those, I don't know, those handrails to grab onto. You have no idea what it's about. So in math class, you have to pay extra attention until you at least get to the point where like, okay, I get this. I see where it's going. Most of the time, though, you never know where it's going to. Occasionally you do. But so many times, you have no frame of reference of what's happening. Why are we doing this? Today's one of those days. Eventually, you're going to get this. There's nothing hard about today once you see what's going on. We're going to spend a whole lot of time on the back on box number 10. Don't assume you know what's going on until I explain it. Just go grab those. All right. I've been told the field day moved to. Did you guys tell me this or did the other class? I've been told that field day got moved to Wednesday because of bad weather. Okay. I don't know if that's true or not, but I put it on the calendar. We'll see what happens. All right. If we do have a snow day, we can't have a chapter 12 test.
Please.
Everybody.
Right. But chapter 12 test will still be on the semester final, so you're still getting tested. We just wouldn't have. Now I'm going to give you a worksheet for homework tonight. Yeah.
Now
All right.
actually be able to.
I will. The copy machine was down this morning, so I don't have the copies written out. So I will have to catch you during student advisement, and I will come to your class and hand you the worksheets. As long as they have copy paper, or it was the toner that was around. All right. So I just gave you the big warning that we're gonna do something you don't have any frame of reference for. It's a little bit weird. It's not that bad. It's not that bad. Most of you are gonna say, why did he make such a big deal? This is easy. Hopefully that's where we get to. All right, this is a lot of stuff. Right? So here we go. Quadratic functions, right? Big thing in Algebra 1 is you get introduced to this symbol right here. We had a whole chapter on this thing. It's just the letter Y. Like, well, why don't you write the letter Y? Well, you can. It's your choice. But when you write this, f of x, you are telling the reader it's a function. Remember, the definition of a function is, well, it's an equation where every member of the input, the x value, only goes to one. Remember the Coke machine? You press the Coke button, a Coke better come out. It's a functioning machine. If you press the Coke button, sometimes a Coke comes out, sometimes a Sprite, the machine is not functioning correctly. Okay? When it is a function, boy, you're going to deal with functions algebra 2. You put the symbol right here, f of x. And it literally just tells the reader, oh, it's a function. The second thing is, remember, as we said, the vertical line test, a circle is not a function. A line is a function because a vertical line will only touch that thing in one position.
Okay, but what if it touches the line at like the very, very point and only hits it?
Well, you can, but we're saying as you move across from left to right, I only ever touch in one spot. True, right here, tangent, right? Geometry kids. You have a tangent right there, but as we move across, eventually you touch the circle in two spots, and it's not a function. Circles are not functions. Lines are functions. The shape that we'll be doing today, you can kind of see on the sheet in front of you, they're functions. Okay. The one that we're going to be dealing today are called quadratic functions. That means x is to the second power, right? Contrast that with a linear function. A linear function is when x is to the first power. You get to algebra 2, you deal with to the third power, fourth power, and higher. Okay. All right. Here's a more complicated quadratic function. Why is it more complicated? You get a +1 on it. Right? Still function f of x. Right. If this really causes you problems, at least in this year algebra 1, forget it. Put a y. Okay. This whole thing, this is what I couldn't never wrap my head around. This whole thing is just the letter y. Like, why does math people make it more complicated? Why don't we just put a y then? Because we're trying to tell the person that's reading your math it's a function. And you get a whole lot of things when it is a function versus when it's not a function. Okay. All right. This will be the most complicated one that we do. All right. Everything's to the second power, so it's quadratic. All right. Also remember that we have this thing called standard form. Standard form is just the way that we write the equation. Julie, you're going to get it if you pay attention. Standard form we have both for linear, quadratic, cubic functions, quintic functions. We have what's called standard form. It's just a way of writing the equation. If it's written this specific way, we call it standard form. It's just a way of writing it. Okay. So the standard form, I don't know if you remember this, but standard form for linear equations looks like this. You got an x and a y. They're both on the left side, and the other number is on the right side. If it looks like this, we simply say it's in standard form. You guys probably remember from this year, y equals mx plus b, right? Well, this isn't in standard form. This is in a different form. We put the x value on the other side, and then we say it's in slope-intercept form. Standard form looks like this. We have a standard form for quadratics as well, too. So the standard form, the first thing you're going to write down is this. Hey, this kind of looks like what we did yesterday. Well, that's the tie-in. So when you are in standard form, well, the y is on one side all by itself, and on the other side is your ax squared plus bx plus c. Yesterday, we said that x was equal to, today we say y is equal to. Go figure. When it looks like that, we say it's in standard form. And when it's in standard form, we get to do a lot of stuff with it. The stuff that we're going to do today. All the ones that I give you today will be in standard form. And literally, that's all I wanted you to write. Standard form. Yes?
Will we eventually get ones that aren't?
Absolutely.
But this year?
Is it tomorrow? Maybe. I have to look at tomorrow's class. All right. Now, we've dealt with this before, not this year, but last year. You were asked free algebra to graph this. Do you remember how you graph this? Well, I didn't teach you last year. Anybody remember how we graphed this last year?
God, no.
It had the word pain in it. A table of pain, right? We graphed this using the table of pain. We graphed last year as well, y equals 2x minus 1. I didn't even tell you about slope-intercept form. We used table of pain to graph that. By the way, you get this nice ability to graph linear equations using y equals mx plus b. It doesn't work with quadratics. Quadratics, you got to use table of pain. This is also why in Algebra 1 you're required to buy, because nobody wants to do the table of pain, right? That's why you have a graphing calculator. And for those of you who have never noticed it, your calculator has on it the table of pain. Take your calculators if you have them. Type in on your y equals, type in x squared and hit enter. Put x squared, just x squared. Just y equals, just type it. You don't have to do this if you don't want to. I'm just showing you where the table of pain is. Okay, don't graph it this time. We want to see the table of pain. Take a look at the top and take a guess what I want you to press. But it's blue, so you need to hit second table, and you got a table of pain. There's the table of pain right there. It's got X and it's got Y, and you can scroll up and down, and you can get any number you want automatically done in a table of pain. There's your table of pain. This is why I don't tell you about it last year, because last year you would use this instead of doing the work. Okay?
Okay, my graph looks like this. I don't know what it is.
Look at mine. Table of pain.
Did you reset like I finished it?
All right. Today's class is not on the table of pain necessarily, right? It is talking about graphing quadratics. Unfortunately for you, the method that we have of graphing quadratics is use the table of pain. All right. So, table of pain now, I need everyone to stop what you're doing and look at the board. This is technically box 2. We'll fill it in here in a second. To manually do a table, I just showed you how to do it on your graphing calculator. Now you can check your work. To manually do a table of pain, does anybody remember what numbers we plugged in last year?
0, 1, 2, 3, 4.
Didn't we use negative numbers too?
I
said-
don't remember.
If you remember last year, I said always pick -2, -1, 0, 1, and 2. Well, I have 1, 2, 3, 4. Oh, I can pick those numbers.
Oh, you just plug them in and then find them.
So let's see, what's -2 squared? What's -2 squared? So what do I write right here? Put a 4 in box 2 right there. Oh, by the way, put -2, -1, 0, 1, 2. So put a 4 right there. Where did I get a 4 from? -2 squared is 4. What's -1 squared?
1.
What's 0 squared?
0.
1 squared. 2 squared.
That's so easy.
There are your numbers. But those numbers actually are together.
That's the line.
They are a
Line.
they're a point. And what did we do last year once the table of pain was done? We graphed those points. I will graph, you don't need to graph the points. There are the points graphed, and that's the shape that quadratics make. What shape do they make?
Oh, whatever that's called.
That's called a parabola. In box 2, write the word parabola. And then, now that I've shown you what it looks like, make sure yours looks like mine. So graph your points now and play connect the dots. Graph your points, play connect. I wanted to make sure you saw what it looks like before you graph it. So graph your points. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Table of pain. You technically can pick any numbers that you want in your table of pain. The issue with parabolas,
That's so cool.
what would happen if we picked -5 to 0? Would we have gotten that shape? We would have gotten half of the shape. The difference is on a line, it doesn't matter where you graph the points on the line extends forever in the same directions or opposite directions, right? For a parabola, if the only points we graph are right here, you don't get the parabola. The issue with parabolas is it's a parabola. In order to get the parabola, you got to somehow find where it bottoms out. If you don't find that point and you only graph that right there, it looks like a line when in fact it's a parabola.
Okay, I think I did something.
You're just repeating parabola.
Okay.
Fabulous.
Does everyone have this graph?
I think so. I hope I do.
You did it wrong. So it's -2, +4. -2, +4. Yeah. Yeah, I didn't want you to really, I was just showing that you could do a table of pain. Why do I create problems for myself?
Someone fix my graph on my calculator, please.
Table of pain. Okay. Everybody has box 2 done, correct?
Sure.
Hey, here's a quadratic. Does it have anything next to it? This is what's called the parent function. Mom and dad. This is mom and dad of parabolas. They have sexist language, but all the other functions that are quadratics are called, anybody want to take a guess? They're not. They're called daughter functions.
Wow.
What about the son? I don't know. We don't do it. We just say daughter functions. No. We say parent function. This is the parent function. It has nothing. It's just x squared all by itself. All the other ones that will change this shape are called daughter functions. Let's look at some daughter functions. So the first daughter function we will look at is, well, what's the difference? But what's the difference? It has a number that's attached through multiplication. Anybody want to take a guess at what this daughter does to the parent function?
Drives
Terrorism.
Okay,
It changes it?
that's what it changes it, but how?
Badly.
Makes it bigger.
That's what the rest of the boxes are about, is how this A will change the function. And it literally is going to change its shape. We already have the parent function. It looks like that. What does the daughter function do? And the daughter, this one is an A. It is attached through multiplication. It could be any number right here. Decimal, fraction, positive, negative. We're going to look at 3 different possibilities. Let's make the number 2. This is box number 3. No, I'm going to do this one just to show you how it works. Okay, I'm going to change it to a 2. I'm going to let A be 2. And let's see how it changes the function. Well, we still do a table of pain. So this time I'm going to throw in the same numbers, -2. What's -2 squared? Times 2. It gives me an 8. -1 squared.
Wait, this is easy.
-1 squared times 2, so forth and so on. You see where I'm getting those numbers?
Wait, so we just
Is everybody with me?
So is it just like a big wider?
Hold on.
Is it a loopy loop?
Let's compare what we just got with the parent function. By the way, that's what it looks like. Well, here's the parent function. What's the difference? Go ahead, Riley.
So for the x, do we just choose whatever numbers or
You're going to get a better feel for it. For the first class, you don't even know what numbers to pick, and the math teacher just says, pick these special numbers because the math teacher knows what numbers to pick. Don't panic. You will eventually, Algebra 2, know what numbers to pick. Hey, what's the difference between the parent and the daughter?
It's skinny.
What's the difference between the parent and the daughter?
It's multiply times 2.
It's multiplied by 2. We could have told that from the start.
You wouldn't.
All this does is change all the, not the x values, but the y values, and it doubles them. Like, no, it didn't. It's still 0.
So do we
It's
just
double 0.
And
Look
then
at your box 3, fill in y values without even looking. Fill in your y values without even looking now that you see the pattern. Okay, who's figured it out? Guess what the y is going to be for yours?
12,
12. Keep talking.
3, 0, 3.
I'm just multiplying by 3. That's it. I'm taking your parent function, which is x squared, and your daughter function, when it's isn't 2, but it's 3, and I'm taking the parent function multiplying by 3. That's it. Well, literally, that's what it says do. It says take 3 multiplied by x squared. Well, I already know what the parent function looks like, 4, 1, 0, 1, 4. I multiply by 3. I'm literally taking the parent function and multiplying by 3. That's it. 4 times 3 is 12. 3 times 1 is 3. 0 times 3 is 3. Well, that's where I get those numbers from. Could you have still taken this number and plugged in? Sure. -2 squared is 4. 4 times 3 is 12. But if you know the parent function, doing the daughter function is no big deal. Graph that sucker.
It's just skinnier.
Sierra says it's just skinnier. Boy, if only life would work that way.
I know.
I just need to change my A value to a 4 and I become skinnier.
It would suck if you were bad at math, though.
You'd have like out of the way.
But the answer is yes, and she immediately noticed that that's literally the effect. Is that when this number is larger than 1, it takes the parabola and it makes it, well, we use that word skinnier as well too. It makes it skinnier. What it's really doing, it's taking the values and it's shooting up the y-axis. Instead of the y-axis being a 4, now it's a 12.
She's a size 12.
It's
now?
still the same x value, but we're going way up here.
So she's a size -12. Wow. She went
Okay.
from 4 to a -12.
So the value of A as it gets increases, what happens to my parabola? It's skinnier and skinnier and skinnier. By the way, you would think that as this goes to infinity, you get a vertical line. Well, infinity is not a number, but you certainly, if you graph, you put 1,000,000 in this in your calculator, it's going to look like a vertical line. But it's not. It's just really, if you finally zoom into it enough, you'll finally see the parabola emerge. But you got to zoom in a lot. If you made A 1,000,000. Okay. Before we do any math, take a guess. What's it going to do? This is box 4.
It's gonna
Divided by half.
If 3 made it skinnier,
It's gonna be fat.
this is what makes it fat. We literally use that word. We also use the term it makes it wider. Okay, fat, I'm probably lying. We don't ever say fat, but we always say it makes it skinnier, but then we never say fatter, but it makes it wider.
It's about like that.
By the way, you know what the parent function is. What are these numbers going to be?
Oh,
You know what the parent function is. What are these numbers going to be?
2, 1/2, 0, 1/2.
You can do, if you know the parent function, this is really simple to do. Just divide everything by 2. 2, 1/2, 0, 1/2, 2. I put 0.5 instead of a half. Yeah.
Whenever it's negative, you flip it.
Because look at the A value, that number right in front of the x squared. In box 3, it's a 3. In box number 2, it was a 1. You're like, where's the 1? Oh, it's just not there. Right. So box number 2 is called the parent function. Box number 3 is, well, what happens when we let A be the value 3? It makes it skinnier. Okay. Now we have a number that's between 0 and 1, and it makes it wider. We actually graph that sucker. It's pretty fat, or pretty wide. Cool. Remember what I said at the start of class? I said no frame of reference what we're doing right now. None whatsoever. But it actually is pretty easy, right? All we're doing is multiplying or dividing. Pretty simple. That's literally everything you need to remember for the first part of class, right there.
To figure out the vertex.
Yeah, we're not there yet. But this is the first part of class, is the what happens when we throw a number. There's one other number I need to use. Anybody want to take a guess? Anybody want to take a guess what happens when A is negative?
It flips upside down.
It's like an upside down parabola.
It takes the function that originally was positive and it
Flips it.
flips it over.
I was right. Why
You were
did
right.
give
Good
me
job.
like that?
Because you got the right answer and the book's not open, so I know you're not cheating, and you literally figured that out by yourself. Bravo. Right. That's why I gave you that look. Listen.
That's because I'm
Okay.
incredible at math.
Genius.
Yes, what a negative does is simply takes the parent function, makes it skinnier by 3, and then the negative flips it. Okay?
It did a cartwheel.
So it looks exactly like box 3, except it's flipped upside down. Now, why are we doing all this? Because we're about to do something where I show you the graph and you got to be able to read it and tell me what's happening. Okay? You know that a negative flips it. You know that an A value bigger than 1 makes it skinnier, and an A value that's between 0 and 1 makes it wider. Okay? Okay. Here's everything that we did on one graph. The parent function is in red, if you can see it. Here's the red. We said if A is bigger than 1, it makes it skinnier. That's this blue one. We said, you can't see it, says 0.5. If you make it between 0 and 1, it makes it wider. And if we attach a negative, it flips it. So this is negative 2x squared. Okay? That's what happens to the A value.
Can I have the homework?
No, we're not there. I don't even have it printed out. All right, here we go. Box 6. We're going to label some parts. Hey, guess what we're going to call that right there?
Vertex.
Since everyone says vertex, let's call it the vertex. That part right there where the parabola changes. You know, the parabola is doing nice and happy. I'm going down, 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 down. Like, oh, I want to change my mind. Let's go back up. That happens whether it looks like this or it looks like this. At some point, it changes direction. We call that point the vertex. Simple enough. Parabolas have many interesting quality, but one of the main one is if I drew a line vertically from the vertex, guess what you just did to your parabola? And you made a carbon copy reflected over itself. In other words, we call that line that goes vertically through the vertex, well, technically last year we called it a line of reflection. We're going to call it the axis of symmetry. Symmetry just means, hey, you got the same. Look, I got the same on the left and the same on the right. They're just flipped over each other. We call that line the axis of symmetry. This is where it gets, okay, now you're throwing out some words. They're just words. Hopefully there's not a single person. Rylan, are you awake? There's not a single person here. Tap them, Nathan. There's not a single person in here that can't see, oh yeah, I can see that. It cuts it in half. You got to be careful cutting it in half. We're just saying it makes something, if you folded it over each other, right, then it would lay on top. Perfect copy. Okay. That's all we're writing on this slide. Vertex, axis of symmetry. Not a hard concept. There are formulas for both. We get to see a little bit of that formula today, but there's a formula for both of these. Algebra 2 really gets heavy into the formula for vertex. You're not going to see that this year. Okay. Well, that was easy. Okay. Parabolas come in two basic shapes. There they are. One face is up, one face is down. I call this the smiley face. I call this the frowny face. You're not going to see that in any math book. Yes.
Would you have a sideways parabola?
You can. It's not a function. Why not?
Because it crosses the line.
Because a vertical line would go through it in two spots, so it's not a function. Okay.
Does that become like
Parabolas. Now, we would still call it a parabola, but it's just not a function. We're only talking about functions here. Parabolas can be, anybody, a better word to name this than smiley face? A would be positive, by the way, for this one. Anybody want to
hold on.
take a guess what we actually call it mathematically? And I'm okay with smiley face, frowny face. Just don't tell that to another math teacher.
The minimum and maximum.
We'll get to that next.
How dare you?
We actually call this, it opens up, or we say concave up. Okay? We call that a minimum. Why is it a minimum? Because look, you see these values on the y-axis? Because I wasn't ready to say it. Now I'm ready. We call this a minimum. Look. Hey, what's the y value where my finger is? About, approximately. So we go from a 10, and then look, the y values are decreasing, 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 decreasing. You get to the vertex, and then it goes back up. This is why this is called a minimum. No, the value is a minimum. It's still a vertex, but at the vertex, you either have a minimum, okay, Sierra,
Or maximum.
or you have a maximum. Okay, we're talking about the y values. You either have a minimum or a maximum at the vertex. Tonight for homework, they're going to ask you what is the minimum, what is the maximum. You just read the numbers. What's the minimum right there?
One.
Right there, what's the y value?
Wait, but then
What's the y value? That's the homework.
wouldn't they be the same as the?
Yeah, but you got to explain what a minimum, what a maximum is, which is why we do all this stuff. That's not all the homework, but yeah, that's the homework. They're going to say, state the minimum, state the maximum.
So wouldn't they be the same as the vertex then?
Well, you find the min or a max at a vertex. They're not the same because one is literally called, I mean, its name is vertex. Its
So then
value are
would you
those
write
numbers.
Minimum and maximum instead of like the number? Or do you write the
No, when they say find the min, the max, they're asking for the number.
But then it would be the same as the vertex.
Yeah, but time out. The vertex is just a name. It's like saying nose. How big is your nose? 2 inches. I don't know. So you got a number and you got a name. Name is vertex. Number is the size of it.
Okay, so when it asks you the vertex, would you say the point?
It's not going to. Yes.
And when it asks you
Yeah,
for
it's
minimum,
asking-
you would just say.
Yeah, but you guys are looking at the last thing and you're trying to get me to tell you 3 steps away. So chill out.
No.
Okay. Also in box 7, we're going to say this is concave up or opens up. Concave, think of a cave, right? Here's the inside of the cave. The concave, right? The concave opens up, so we call that concave up. Guess what we call this one?
Concave down.
Concave down or opens down. You're going to see both of these words. They're going to say, is it concave up or concave down? Or they'll say, does it open up or open down? What are they asking you to do? They're literally just saying the graph of it. Does it look like a smiley face or does it look like a frowny
I've
face?
never actually seen people around like that.
Well, you get the basic idea. Oh my God,
Just tell us.
just stop.
We can stop.
Why do you guys do this to
What's the
yourselves?
range?
We'll get there.
The range is the y value in the domain.
All right. You guys need to listen to Sierra more. Okay, so the vertex, hey, it's literally right there. What are the coordinates of the vertex? That's the min and the max. What are the coordinates of the vertex?
1.
0, 1. Is that a min or a max?
That's a max. Min.
That's a minimum. Look, the y values start at 10. They go down, 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 down to smallest value is a 1, and then they go back up. So the vertex, well, it's right there. It's at 0, 1. That's just the location. That's not its value. That's just its location. Well, this one, the min is 1 of the entire function. Does it stop right here or does it go on forever?
It goes on for
So what's the max?
0.
Infinity?
The red line, I left off the arrows, goes on forever, never stops. So the max value, remember we're looking at y values, Sarah said. Just look at the y values. Yeah,
So when we draw it, we put the arrows on.
you should.
Do we have to?
I get mine all from Desmos, and Desmos never puts arrows on the end of it, so therefore I don't get arrows.
Will you dock points?
No, I'm not going to be that bad.
That's what my teachers used to do.
Okay, look at this one. Where's the vertex? Oh, it's right there. What are the coordinates?
0, negative 1.
0, negative 1. So what's the maximum value that it reaches?
Negative 1.
It reaches a maximum value at the very top at negative 1. Let me catch up with you. But the minimum goes down to negative infinity. Negative infinity. We're talking about the red line. The red line doesn't stop right here. It continues all the way down to negative infinity. Infinity is not a location. It's just that we say it goes through negative infinity.
Wait, but what if it's off the line?
What?
What if the whatever.
Parabola.
What if it's off the line? What is it?
It still will have a min and a max.
So what would you write down if it were off the line? Would
What do you mean
write the-
off the line?
Like,
You mean shift it up here?
yeah, like what,
It's still, it has a
would
vertex.
you write the point?
Yeah.
Okay. All right.
Okay. Let's do these real quick, and then we got to get to the last
So that would
thing.
be the same as the vertex.
This is box 10. One of the numbers of the vertex, yes. Okay, here we go. The vertex is at 0 what? The vertex is at 0, 4. Okay?
How do you know?
You just look at it. It's right there. It's at 0, 4. Okay. Okay. Does this have a min or a max?
No, it's infinite.
Does it have a min or a max?
Yeah, it does. It's a 4.
So it's at 4. So the max is at 4. Now the min would be negative infinity. Why? It's going down to negative infinity. Next one. What's the vertex?
I don't know what that one is.
2, 1. That was easy. Oh, I did that one down there next. 2, 1. What's the minimum it goes to? What's the maximum it goes to? There you go. All right, I'm going to stop it right there. You can do the rest of those all by yourself.
What is dominion and range?
Well, we're not there yet. That's the last thing.
I know what it is.
Now I'm ready to throw things.
That's domain.
Okay. Dominion. No, it's domain range. All right, last thing. Okay, write this down. Domain. Sarah already said this if you were paying any attention. She says the x values. It's a little bit more than the x value. It's the x values that you're allowed to plug in to the equation.
So it's just something of pain?
Anything that you could plug into the table of pain, yes.
Alright.
The range is everything that you get out of the table of pain. You're like, well, how am I going to figure that out? You're going to look at the graph.
Wait, would you say like I is less than 1?
How about we go through one first and then ask questions, okay? Domain are the allowable numbers that you can plug in. You're going to like the answer to this one. The range is going to be the only one you actually got to calculate. You'll see why here in a second. Pun intended. Do you have this written down?
Yes.
It's written down in our box.
Okay, nice. So here we go. I'm going to give you tonight for homework a graph. And I'm going to ask you, what's the domain and range? Hey, you see the function right here?
Yes.
Is there an x value that you are not allowed to plug in?
No.
Like, is there any number that you're not allowed to square? 0 squared is 0.
1.
1 squared is 1.
No.
Is there any number that you can't square? You can square a negative.
Infinity.
We just did a whole homework on it, yes, last night. Is there any number that you can't square?
No.
So guess what the domain is? Every number that exists. Okay.
So infinity?
We have a way in math of writing that. We can either put the words all real numbers, or we put the symbol for it.
What is the symbol?
The symbol for it is an R with one extra little thingamajig. I don't know what we call it. It's an R with an extra vertical line on
So
it.
that's all domain.
This doesn't mean, this means all, it's R for real numbers.
Yes, but so we put that for every single domain.
Well, are there any quadratics that you're not allowed to square? In other words, are there any x values that you can't square?
No.
So it turns out, are you listening? For every single answer, if it's quadratic, the answer will always be for the domain,
All real numbers.
all real numbers. Because you can square it. Now, this is not true for all functions. For instance, the square root, you can't take the square root of a negative number. So if it was y is equal to the square root of x, well, that has a graph, by the way, but we can't plug in negative numbers to this. So the domain for not all functions is all real numbers, but for quadratics, it's all real numbers.
Okay, can
So
you
you're like,
explain
do
why?
I just literally write that R-looking thing for all the answers? The answer is yes.
So basically, to get that point, just don't forget it.
Right.
Can you explain why?
Range, last thing of the day. You ready?
Yes.
No, it's not. I got 2 minutes. Look up here. The range. Are you paying attention? The range is where numbers the red touches for y.
Can you write down all those?
Oh my gosh.
So what numbers does the red touch? Y values. Well, it touches 0. Does it touch 1?
Yes.
It sure does. This point right here is 1, 1.
And 2, 2.
And 2, 2.
And 3, 3.
All right. So what y values does it touch?
All positives.
Greater than,
Does it ever touch -1?
No.
greater than
So what y values does it touch?
greater than
So which ones are those? And somebody's already said the
I
answer.
said it, positive numbers.
Okay, but 0 is not positive or negative. We said it touches 0.
greater than or equal to 0.
So
Greater than or equal to.
Science.
Why is it only a right answer when you
I don't
say
know
it?
what he said.
yeah, but when you're the only person in class, I got to wait till at least 3 people say it. And I already pointed to you. I said yes, one person said it. Okay, do you get where I'm getting that from? The red line, the y values, not the x values, but the y values that it touches. Well, it touches every y value that's either positive or 0. Never gets below 0. So we just put greater than or equal to 0.
Are you serious? Is that all? This is like way too easy.
I'm gonna throw things. Okay, let's do 2 more. We'll call it a day.
You could have taught this to us like last year.
Okay, what is the domain of any quadratic function?
All real numbers.
You put that R thing, you're done. Or the words all real numbers. What values does the red line touch for y? What?
Less than or equal to 0.
Negative
It
1.
never touches negative 0.1.
You're stupid.
Less than or equal
Less than or equal
to -1.
to what?
0.
-1. Can you see that? Kaylee? The red line if I think about just the y values, well, the biggest y value it touches is -1, and then it touches every other number. Look at the red line, touches all those things. So less than or equal to 1. So on maxes, stop.
Okay.
Stop. On maxes, it's always going to be a less than or equal to, and on a min, go back to my min, it's always going to be greater than or equal to. Like it's a paradox. Right? Okay, that's it.
Beautiful.
For those of you that actually did the box 10, there are the answers.
Yes, I did all of them.
So this is 19 pages of homework that I either completed or have completed that I did.
And you have your name on everything, and it's all labeled. So it's not going to be like a random sheet of piece of paper. And like, well, I'm not sure which assignment that is. So, yeah, but this is page, or is this, what assignment is this? Okay, I just need to do one thing. I'm happy. But I need you to go through all, obviously you don't do it on this one because I know it's. But go through everything, and then don't forget to turn in for student advisement, okay?
Okay, sure.
And I will come by student advisement, and if I haven't collected your homework, I will collect your homework and hand you your worksheets. What's up?
I didn't get the chance to watch the video yesterday, so can I watch it tonight and
Yeah.
turn in the homework?
Absolutely. And you definitely want to watch because it's a very important class. And it's